Hello students, and welcome again to my channel. My name is Mr. Meshak Ngige, and welcome to eMaths with Meshak Ngige. So kindly remember to subscribe, share, and also comment how these lessons are being helpful to you as we dive in and share in engineering mathematics, both civil, we have electrical engineering and also mechanical engineering. These are the mathematics that indeed come in your final papers. So today we're going to be checking a topic on numerical analysis, and we're going to be checking the NEC October-November 2024 series, and this was question number 1B, and it was on Newton Gregory forward interpolation. So this question just from the request of one of the viewers is a question that is asking you to solve the function that gives you this outcome. So remember, in Newton Gregory forward and backward interpolation, we are dealing with a data where you have the value of x and also the outcome of the function that gives you an outcome when you insert the values of x. Okay, so now in this question, so you have been told, one, the table 1 represents a cubic polynomial fx. Now before we start solving, this statement is very important because you have been told that it is a cubic polynomial. So one thing, your highest power in the variable of x, it will be cubed. Are we together? Then when you go to something we call the differences, since it is a third polynomial, the maximum value that you can have in terms of the differences will end at the third difference. The fourth difference will give us a 0, and that knowledge actually sometimes it will help us in solving some errors that occur in entering some data. I think I covered that before, but this statement also can enable us to understand that if this question is a cubic polynomial, then it means that in the entry of your data, the fourth difference in terms of the differences should be all zeros. The data in terms of differences should not continue once it reaches the third actually, so that the fourth becomes 0 and so on and so forth. So we know one thing, when we're getting our differences, one thing we are so sure is our fourth difference will be 0. So what do? We start by creating the table and finding the differences. So we shall have the vertical table now. So you have x, you have f of x. So I've said our differences will go up to the fourth. So we'll have the first difference, the second difference, the third difference, okay, this one comes here, then the fourth. But what do you know about the fourth? There will be all zeros, and we shall verify that. Now again, when it comes to the entry of data, kindly, because your books are always spaced, either ruled or boxes, kindly leave a space, insert the value of x and fx. Alright, then leave a space because you're going to be getting the differences, and it is always important because when you get the differences, we need to have spaces in between so that it can help us in finding the correct differences, so that you don't have all of them in the same line. Are we together? So we have -1, 8, we have 0, -2, we have 1, 0, we have 2, 4, we have 3, 16, then we have 4, and we have 42. So we now get our differences in the values of x. So we have -2 minus -8, and that will give you 6. Then 0 minus -2 will give you 2. Then you have 4 minus 0, which will give you 4. Then you have 16 minus 4, it will give you 12. Then we have 42 minus 16, that will give you 26. Then again, 2 minus 6 gives you -4. 4 minus 2 will give you 2. 12 minus 4 will give you 8. Then you have 26 minus 12, that will give you 14. Then subtract 2 minus -4 gives you 6. 8 minus 2 gives you 6. 14 minus 8 gives you 6. Therefore, as we said, our value in the fourth difference will give you what? 0 and 0, because 6 minus 6 is 0 and 6 minus 6 is 0. So that is very important in terms of filling the table. Now, how do we get the value of x? How do we get the value of fx? That is the value of the function. So what we say in terms of the differences, we need to identify p and some few values here and there. But what we use is this first difference here. We shall use the first difference, assuming that our x value lies there. So we'll use the first difference table. The differences, the outcome, in the differences in the entry of the data, the first entries in the data. So you can see I have one number at the top, so every number here at the top will always be 1, so there's no other number above. So we'll take the differences which come by that. So from this one, now we get the value of p. And how do we get p? So you can just write it here. It is given by xp minus x naught over h, where xp is the value that you are finding, x naught is the value above the value that you are finding, h is the common difference all through the values of x. So therefore we have p. Okay, we have p. So p, what are we finding? That is our xp. We're finding x. Are we together? You can remember when you're finding, for example, f 1.5, the 1.5 value is what you'll put here. So in our case, since you're finding the function, we are finding the value x. So we'll have x. Then subtract the value above. So we assume our x is here. Then the value above x is -1. So we'll have minus, then our value is -1, -1. So the value becomes what? +1. Then all over. A common difference in the values of x, you can take any value. 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is also 1. So over 1. So therefore our value of p will be x plus 1. Are we together? Then, depending on where the values of x, the values of the differences reaches, will determine where you're going to get the values of p's. Because we always get p, we get p minus 1, we get p minus 2, p minus 3, and so on and so forth. That is with respect to the formula, the forward difference. So therefore, we'll get p minus 1. So we are saying it will be, so if this is our p, so it is x plus 1, then minus 1, which will give us what? Which will give us x. Right, together? Then p minus 2 will have x plus 1, then you subtract 2, which will give us x minus 1, because we'll have x plus 1 minus 2 will give us -1. Now we shall reach here, p minus 2. Reason being, we are going up to the third difference. Are we together? We are going up to the third difference, and we shall see why that is the case. So we have that. Then, so we have p minus 1, we have p minus 2. Values defined by all that. Okay, so I always love bracketing them because of the signs, because when you shall be inputting them in the equation or the formula, then the brackets really matter. Then we get our differences. Our first difference, therefore, now we start with the value of fx or f naught. We find the value of fx, that is with respect to the differences. So we shall have the first value fx, sometimes it is called f naught. It is the first value here, which is -8. Then if you get the first difference, our first difference is what? 6. Our second difference is given by -4. Our third difference is given by 6. And our fourth difference is 0. Okay, so we have that. Now from there, we just replace our values and solve now for the value fx. Now, so what does the formula say? The formula say, if you want to find f, so in our case here we're finding fx, it will be given by f naught or fx, the first entry in the value of fx, so we have that, plus then we have p, then our first difference, plus p minus 1, our second difference, over what? Over 2 factorial, plus p minus 1, p minus 2, third difference, over 3 factorial. Now remember here, we shall only reach at the third difference, because even if we input the value of the fourth difference, our fourth difference is what? 0. And therefore, any term that we shall be here shall be multiplied by 0, and the answer shall give you what? The answer shall give you 0. Okay? So, we are saying now this one is our f cubed. That's the third difference, then over 3 factorial. So we can now, since we know this is our formula, we can now replace our values. Okay? So let's do that. So now we start with our fx. Our first entry value here is negative what? Negative 8. So we have negative 8. Then plus we have p. Okay. Sorry, we already have the value of p. So what is our p from this? Our p is x plus 1. Our first difference gives us what? 6. Okay, so we have 6 plus we have p. Our p again, our p is x plus 1. Okay, our p minus 1 gives you what? P minus 1 gives you x. So we have x. Our second difference is negative 4. Okay, so we can always do this. We can replace this value here, because we have a 4 negative, which is 4 here. We can change this one to be what? A negative. Right, together, because our 4 is negative, so instead of putting the negative here, we just replace it here with that value. So we have negative 4. Then plus, go to p. P is x plus 1. Then we have p minus 1 is x. P minus 2 is x minus 1. Then our third difference is 6. Then all over. Now remember, this one is over 2 factorial. 2 factorial is what? 2. Then this one is over 3 factorial, which is 6. Okay. Now we can go on and simplify further. So we have negative 8. Okay. So I can have plus. This one can open this bracket. So we shall have what? We shall have 6x plus 6. Now these 2 can cancel with this one here. So we can have a 2 there. So 2 times x gives us what? 2x. Right, together. Then 2x can open this bracket. Now, okay, so we can multiply the 2x and this one first. Before we have the negative there, we can put a negative there. So 2x times x gives us 2x squared. Then 2x times 1 gives us 2x. We can have that one as our output. Then 6 goes here once, 6 goes here once. Now, something interesting here, we have an x plus 1 and we have an x minus 1. And we know, just let me just put it as an NB here, that when you have a plus b multiplied by a minus b, the outcome is always a squared minus b squared. And we can see therefore this one occurs in that form, that we have an x minus 1, we have an x plus 1, x minus 1. So therefore this part and this part, okay, the two factors here will become x squared. Let me just put it here. We'll have x squared minus 1. So when you multiply this and this, it is x squared minus 1. But you have an x outside here. Okay, this and this gives you this. Then you multiply by an x outside. So now open this bracket here. So you shall have plus x times x squared gives you what? X cubed. Then negative 1 times x gives you negative x. Right, together. Yeah, so these are just using some knowledge that we know from algebra for us to simplify that. Now from this point, we can now open everything here. So we shall have negative 8 plus 6x plus 6. Now you can open the bracket, minus 2x squared. Then this one is also minus 2x. Then you have plus x cubed. Then you have minus x. So that is when you open it. Therefore, collect cubic terms together, collect square part together, and put them put them together, add and subtract them. So x cubed, we only have x cubed, so we shall have x cubed. Let's go to x squared. Do we have any other term with x squared? No, there's only one term, so negative 2x squared. Then you collect the terms with x. Okay, so you have 6x, all right, minus 2x. That gives you what? Gives you 4x minus x, gives you plus 3x. So plus 3x. Then lastly, we collect whole numbers that do not have the variable x. So we have negative 8 plus 6 gives you negative 2. So we have negative 2. So the cubic equation that gave you this outcome here is that particular equation. And how do you know that that equation indeed is the equation that you have been looking for? Look for the simplest term that you can have here and replace it in the function here. Okay, so we can take a 0. Okay, 0 is quite simple for us to work with. So take 0, replace, so this one is fx, yeah? So replace zeros in the values of x. So where you have x, replace 0. So 0 cubed is 0. 0 squared times 2 is 0. Plus 3x 0. 3 times 0 is 0. Then 0, 0, 0, then minus 2. What do you remain with? It remains to be. So if you take 0, this part will be 0, minus 0, plus 0, minus 2. And the value will be negative 2. And is that the outcome when you put your value being 0? Yes. When you put your value of x being 0, the answer gives you negative 2. Therefore, students, that is how you find the function fx of any equation that has been given, and the outcomes have been recorded in the what? In the table using Newton-Gregory forward interpolation formula. And kindly note also that when you get the equation here, and for example you have been asked to find the value, let's say you have been told use Newton-Gregory forward interpolation formula to determine the value of fx, hence determine the value of f. Maybe let's use a value that is outside here, that is outside the limits. So for example f5. Okay, for example I've been told to find f5. So f5 is not in the table. When your value of x is 5, that is not found in the table. But now, since you already have the equation, you can just replace your value of 5 and replace it in the equation. So if, for instance, if we replace 5 here, we shall have 5 cubed minus 2, 5 squared plus 3, then you have 5, then you have minus 2. 5 cubed gives you 125 minus 5 squared is 25. 25 times 2, that gives you 50, plus 5 times 3, that gives you 15. Then you have negative. Then you have negative of what? Negative of 2. So you can add, then subtract. So you have 125 plus 115. 125 plus 15, that gives you 140. 140 minus 50, that gives you 90. 90 minus 2, it gives you what? It gives you 8. So you don't need to find a way in which you need to calculate f5, and that is true for any other value inside the table. So if you are supposed to find the value of 2.5, you just replace the value 2.5 there. If you are supposed to find the value of 1.5, then you just replace the value of 1.5 and you find the solution. So thank you so much. Kindly remember to subscribe, share, and also comment, and let us keep learning. Thank you, and see you in the next lesson.